In this video, we will learn about the observer design pattern and how to implement it using C++ code. Observer is a behavioral design pattern that allows objects to listen for events and respond to the events when they occur. If you've ever built a program where there was a button that performed an action when it was clicked, you most likely have used the observer pattern, perhaps without even knowing it. A real-world example of this would be subscribing to receive a set of emails. Perhaps you have an email subscription. Your inbox becomes an observer and notifies you when new messages are available. Let's learn how to implement the observer design pattern using C++ code. Up at the top of the code, we will include the list header file. Then we will create a class named inboxBase, and inside of here we will use the public access modifier. We will have a virtual destructor for this function, and a virtual function with a void return type named update that takes in one parameter, a constant string named message_from_server, which we will mark as a purely virtual function by setting it equal to 0. Next, we will create a class named serverBase, inside of which we will use the public access modifier. Inside of this class, we will have a virtual destructor for our class, a virtual function with a void return type named attach that takes in one pointer to an inbox base named inbox, a virtual function with a void return type named detach, which takes in one pointer to an inbox base named inbox, and a virtual function with a void return type named notify. After that, we will create a class named server that extends the server base class with public accessibility. Inside of this class, we will have a list of inbox base pointers named list of inboxes. We will also have a string named message. Next, we will utilize the public access modifier. Let's create a virtual destructor for our server class that outputs the string server being shut down, and then a new line to the console. After that, we will override the base class's attach function. Inside of this function, we will add inbox to the list of inboxes using the pushback function. Then we will override the base class's detach function, and inside of here we will remove inbox from the list of inboxes. Next, we will override the base class's notify function, and inside of here we will have an iterator that iterates over a list of pointers to inbox bases, which we initialize to a value of list of inboxes.begin. After that, we will make a call to how many inboxes, a function we have not yet written, but will write in a moment. Then we will use a while loop that runs while iterator is not equal to list of inboxes.end. Inside of this while loop, we will call the iterator's update function and pass in message. Then we will increment the iterator using the ++ operator. Next, let's write a function that has a void return type named createMessage, which takes in one optional parameter, a string message that defaults to a value of empty string. Inside of this function, we will set the member variable message to the message parameter passed into this function. Then we will make a call to the notify function. After that, we will create a function with a void return type named howmanyInboxes, inside of which we will output the string there are, then the size of our list of inboxes, and then the string of inboxes in the list, followed by a new line character. After that, we will create a class named inbox that extends the inbox base class with public accessibility. Inside of this class, we will have a string variable named message_from_server, a server named server, being sure to include the ampersand in front of the variable name, a static int named static number, and an int named number. Then we will use the public access modifier to create a constructor for our class. After that, we will make a call to s.attach and pass in this. Next, we will output inbox, then inbox's static number, incremented using the prefix ++ operator, then the string initialized, and then a new line to the console. After that, we will set number equal to inbox's static number. Then we will create a virtual destructor for this class, and inside of there we will output the string inbox, then number, then the string destroyed, and then a new line to the console. After that, we will override the update function, and inside of here we will set message_to_server equal to message. Then we will call the printinfo function, a function we have not yet written. Then we will create a function with a void return type named removeInbox from the list, inside of which we will call server.detach and pass in this. Next, we will output the string inbox, then number, and then the string remove from the list, followed by a new line character. After that, we will create a function with a void return type named printInfo, inside of which we will output inbox, then number, then the string a new message is available, and then a new line to the console. After that, we will have an int static number that we set equal to 0. Time to test our code. We will go inside of C++'s main function. Let's create a pointer to a server named server that we set equal to a new server, a pointer to an inbox named inbox1 that we set to a new inbox with server passed in, and a pointer to an inbox named inbox2 that we set equal to a new inbox with server passed in. Then we will output a new line to the console. After that, we will make a call to the server's createMessage function and pass in the string message1. Then we will output a new line to the console. After that, we will make a call to inbox1 remove inbox from the list function, and then output a new line to the console. Next, we will make a call to the server's createMessage function and pass in the string message2. Then we will output a new line to the console. After that, we will call inbox2's remove inbox from the list function, and then output a new line to the console. Finally, we will delete server, inbox1, and inbox2 respectively. Let's scroll to the top of the code and remove the const keyword from lines 10, 16, 17, and 18 respectively. When we run the code, notice that our inboxes are initialized. Both are added as observers to the list, so both get notified when a new message is available. Then, inbox1 gets removed as an observer, so only one inbox, inbox2, remains in the observers list. Inbox2 gets notified that a new message is available. Then inbox2 gets removed from the list. After that, the server gets shut down, and then our inboxes get destroyed since the program is no longer using them.